All right, take out your 5-1 notes using the calculator degrees. So before we even get started with taking notes, I wanted to show you how to do this on a specific calculator. So if you take a look at this specific calculator, some of you have this one, but I want to turn it to degrees. So what you'll do is you'll click on mode and then either arrow over depending on which one you want. Do you want radian? Do you want degrees? Once you have the one you want, you press enter and then clear. And then as you can see up here, it says degrees, and that's what you want. Most of them are on mode, or you can find them on mode. Figure out how to do that. Maybe pause the video and then come back. Make sure that it's on degree, otherwise your answers will not match up with what we're getting in class today. All right. So we're going to start using the calculator. I think some of you will find that really nice because then we don't have to always think about our families and the unit circle and all that stuff. So first things first, you put your calculator in degrees. If you've got that, you're set to go. So we want to talk about the difference here of the capital letter A and the lowercase letter a. So what is that difference? So we'll start with our little lowercase here, arc cosine. Let's just say of square root of 2 over 2, okay? Or another way of writing this is the cosine inverse of square root of 2 over 2. Those mean the same things. And they represent an infinite set. What does that mean? It could mean every single value, no matter how many times you go around the circle. And another way of saying this or writing this is the set of an angle measure or angle measures whose cosine is square root of 2 over 2. And remember, that's if you were to type that in your calculator, it would be a decimal. So really, you're trying to find the angle measure. And we've done that before in geometry and algebra 2. So we'll talk more about that when we get to some more concrete examples. Now, the difference, though, with the capital arc, what does that mean? So if we were talking cosine again, it represents the principal values. In other words, the calculator, what the calculator will give you. What that calculator is going to do for you, okay? So just a little bit of difference here is our arc sine. Let's just say we're working with sine. That's our calculator values, whatever they're going to give us, whatever the calculator yields. Keep in mind that's the capital. And then our arc sine is all solutions. And you kind of remember this, that k, where k is an element of integers. So that's really all solutions. And we've worked with that last chapter. Okay, so let's talk about our principal values then. What does that look like? So I was just going to list a couple things for arc sine. What's really happening here is your calculator is telling you what the values are that makes the inverse function a actual function. So it limits the how high and how low it can go for the y values to keep it a function. So it passes that vertical line test, and that's what those numbers are. So similarly, for the arc cosine, we have from 0 to pi. Again, that's saying it's limiting it so that this is a function. When you graph the inverse of cosine, making it a function. And similarly with all the other ones, You got these going on. I gotta erase these, sorry. Did not mean to put those. All right, and let's see. We have arc, cotangents. Again, limiting the values so that it is a function. The inverse of sine, inverse of cosine, or what have you, is actually a function where when you would graph the inverse. And I mean, this kind of makes sense too. When we talked about secant in the last chapter, that was the inverse of cosine. And similarly with cosecant. Okay, so those are kind of making sense to us, hopefully. The other thing is your calculator. It's going to give you one solution in these intervals that I just listed. In those intervals. So the calculator is going to give you one solution, and then it's our job to be able to figure out and make sure that we're getting all of the answers that the question's actually asking you for. So sine, when your calculator gives you an answer, is either going to give you an answer in the first quadrant or the fourth quadrant, depending on the value you're looking at. Cosine is going to give you the first or second quadrant, because think about it. If you're matching this up, isn't negative pi over 2 and pi over 2, right? That would be first or fourth quadrant if we were talking about those intervals. Same thing going on with 1 and 2. Isn't 0 and pi between quadrants 1 and 2, right? 0 and pi is between quadrants 1 and 2. That makes sense. And then the last one, and we really don't work too much with the other ones, but tangent would be first and fourth again. Check it out. This is first quadrant, or fourth quadrant, and then first quadrant. So those are matching up with those intervals that I gave us. All right, the fun and easy part. There's not a whole lot of thinking here in terms of can you use your calculator. So couple things, use your calculator, and then rounding. Everybody gets rounding wrong, I don't know why, but 10,000. So that's 4 decimal places. So make sure you're looking at the fifth. So in your calculator, type in sine of 10 degrees. If you do not have your degrees on in the correct mode, then you're going to get the wrong answer. The answer here should be 1.1736. Cosine of 230, negative 0.6428. So be checking these. This one, pretty straightforward. Type that in. Now, it should be positive 0.2679. Now, the question comes up about number 4. How the heck am I going to enter this in my calculator? You see that it's secant. Well, secant's the reciprocal function or the inverse function of cosine. So I am going to actually type in 1 divided by cosine of theta. And what's really nice is I can actually show you what I'm typing in if you want to see that. And I'm just going to use this one because that's the only calculator version I have to help you. I do have a graphing calculator, but not everybody has one of those either, so it really doesn't make sense. When you're doing this one on your calculator, guys, you want to do the 1, and I'm going to make a fraction, and then I'm going to put cosine, and then I'm going to put 786 and close it. And then I always arrow over just to make sure that I'm out of the denominator and hit enter. So I should be getting 2.4586, and that's exactly matching up. So again, take a look at what I did. I did 1, I did my fraction button, I did cosine, 786, I closed the parenthesis. All right, so again, what did we get? We got 2.4586 if we round correctly. All right, going to number 5. What are we typing in for this one? Oh, it's cosecant. So we should be thinking 1 over sine. So you're going to type in that same information. Make sure you put a negative 274, and you should get out 1.0024. Again, round correctly. All right, number 6. Oh my gosh, it's cotangent. Well, you could type this in your calculator, and it would be 1 over tangent of theta. What happens is it says can't divide by 0. Well, why is that? We should start recognizing. Well, 540, where does that land you in terms of the unit circle? Lands you here. How do I get that? I can divide by 360, I could divide by 180, I could figure out where that is based on using my calculator if I wanted to. But it is at pi, or 180 degrees, or negative 180 or negative pi, depending on how you want to look at it. However, the ordered pair there is negative 1, 0. And cotangent is cosine over sine. So, in terms of this fraction that we're looking at, that ends up being undefined. And no, your calculator's not messed up. Maybe you typed it in wrong, but not in this case. This one came out to be undefined. I think we can work out our calculator. Hopefully you're getting those same answers. If not, you can always ask, come in and ask. All right, last but not least, and this will take us to the end for 5-1. Yay! Use the principal values to solve. So what does your calculator tell you? But your answer can only include angle measures from 0 to 360, not including 360 degrees. Look at this. That says equal to. This one does not. Also, it says round your answer to the nearest hundredth. Make sure that you are rounding to the nearest hundredth. That's 2 decimal places. So notice all of these ones. We are looking for the angle measure, angle measure, angle measure. Again, angle measure. If we're looking for the angle measure, we already have the exact value. Technically not the exact value, just the value, because 0.44, I'm pretty sure, was not an exact value from our unit circle. So we're probably not going to get angle measures like 3 pi over 2 or 5 pi over 6. We're going to get some sort of decimal, hence the directions as well, that say round. All right, so let's start this off. How many answers are we going to get? Well, sometimes we're going to get 1. Sometimes we're going to get 2. But we're not going to have an infinite solution because of the directions here, okay? So I'm looking for the angle measure, so I want to know what angle gives me this value. So I'm going to do the cosine inverse of 0.44 and get an answer. Here's the thing. My calculator is going to give me one answer. Remember, one answer that fits in here. That fits in between 0 and pi. And then it's going to be my job to say, is there more than one answer that fits? If so, where is it? So if I type in cosine inverse, take a look at how you type that in. You do second cosine, and then you type in 0.44. And you get an answer of 63 point, and it says round to the nearest hundredth. So if I'm rounding, that actually comes out to 63.9. So 63.9. Okay, great. That's degrees, remember. We found it in degrees. Our calculator's in degree mode. This angle is actually in the first quadrant, which makes sense. Cosine is positive in this first quadrant. When else is cosine positive? So this is our 63.9. When else is it positive? It's also positive in the fourth quadrant. So keep in mind, this little angle here is at 63.9. So is this 63.9. Well, how do I get this angle measure that goes from here to here? because I don't want to put negative 63.9. That won't fit inside my answers here. I want to figure out how do I do that. I can think about this as a whole circle, and if I take this piece out right here, which is at 63.9, I'll get this angle that I drew. So I gotta do, if I make this whole circle, right, that's 360, and I take away 63.9 degrees, that will give me my other angle measure that ends up in the fourth quadrant. And that comes out to be 296.1 degrees. All right, so that being our other answer in the third quadrant. So here is my solution set that fits within my parameters from 0 to 360 degrees, 63.9 and 296.1. And using those curly brackets, right, they represent our solution set. So that's a great way to write it. You should start doing that. All right, let's try number 8. Number 8, we need to find the angle measure. So we're going to do the sine inverse of 0.78. Our 7/8, our calculator is going to give us one answer, which is 51.26 degrees. Think about where this is. Remember, sine has to be, okay, I love my smartboard. Back check. Sine has to be positive because this value is positive. Well, sine is positive in this quadrant, which this is the 51.2. And sine is also positive in this quadrant. Well, let's think about this. If this is 51.2, this also has to be 51.2. So I want the angle that goes from here to here. If I use this angle and this angle, that makes 180 degrees. So if I subtract the 51.2, I'll get what's left over. So I'm doing 180 minus 51.2. And that's going to give me the other angle in the second quadrant, which comes out to be 128 degrees, or 0.74 degrees. Thank you, sorry. So again, solution set, 51.2 and 128.74. Again, why do we have those two? Why aren't we using third or fourth quadrant? Because we want the sine value to be positive. Positive sine values happen in the first and the second quadrant. Also, you're like, why didn't the calculator give you both answers? Both answers aren't going to be coming from the calculator. The calculator only gives you the principal value, which is between negative pi over 2 and pi over 2, or negative 90 degrees and positive 90 degrees. All right, let's move to tangent. All right, tangent, same kind of concept here. The tangent inverse of 0.33. And what does that look like to us? What does it come out with? 18.26 degrees. Okay, so tangent is positive in the first quadrant. So this little guy is 18.26. Makes sense. So that's going to be one of our answers. But then how do we figure out what our other answer is? Well, where else is tangent positive? It's got to be positive, not here, because one of those is negative, not here. Sine or cosine is negative there. The other one's going to be in the third quadrant. Well, again, if this is 18.26, so is this. But how do I get that angle measure? Keeping in mind, I want the angle measure that starts at 0 and goes all the way and stops there. So if I look at just this part here, that's 180. So if I add the 18.26, that should land me in the third quadrant. Now, here's the other thing. When you write this, if you write your two answers and they don't land you in the quadrants that you said, which for us was the first and third, then you did something wrong as well. You either added or subtracted incorrectly. So my solution's at 18.26 and 198.26 for our solution. All right, we're going to keep going. We got 3 more to go. This one, number 10, is a little bit trickier just because of what the calculator tells us. So we're still going to do our sine inverse. We're still going to do negative 0.53, but the answer that comes out is a little bit different than what we expected. Negative 32.01. Now that's degrees. Think about where our solution set has to be. Our solution set has to be between 0 and 360. This is negative 32. That does not land in the correct quadrant or the correct solution set. So we have to give the correct answers here. So we're trying to figure out, when is sine negative? What angles makes that happen? Sine is negative in the third and the fourth quadrant. So we're going to have to use that to our favor to figure out our answers. Now, if I drew the angle negative 32.01, wouldn't that be here? So 32.01, I'm just going to write it as a regular positive angle. That's the same as this guy, right? Those are vertical angles, blah, blah, blah. So, this would be 32.01. And think about the angles that we want. Maybe you can do this in your head. Maybe you have to draw it out every single time. Not sure why I said vertical angles for some reason. Scratch that. But I want this angle and I want this angle. So if I connect those two, keeping in mind the 360 degrees and the 180, this is 180. If I add 32.01, that should get me one of my answers. That's going to get one answer. And then for the other one, sometime if this lets me open it, okay, just trying to keep it so you can see it. This whole thing would be 360. So if I take away, do 360 and take away 32.01, that'll land me in the fourth quadrant and get my other answer. So 2 answers that I have here. The first one, or I'll say the second one just because I'm in green, 327.99. The other in the third quadrant is 212.01. So my solution set is 212.01 and 327.99 for number 10. All right, last 2. Number 11. Let's type that in our calculator and see what we get. When we do our cosine inverse, too far. So cosine inverse of negative 0.51. This is going to give us an answer of 59.34. Okay, this is confusing to me because I expected, based on cosine being negative, I expected it to be in the second and the third quadrant. This 59.3 is actually here in the first quadrant. So how can I connect those two? This is 59.34, which means this is also 59.34. So what I can do is, remember what I'm looking for, I want the angle that ranges from here to here. If I finish this off, that gives me 180 degrees. So I'm going to start with 180 and take away this 59.4 or 0.34. And that'll help me get the correct answer for the second quadrant. So I have to subtract 59.34 to get one of my answers. That answer comes out to be 120.66. How am I going to get the third quadrant? The third quadrant, keep in mind, this is also 59.34. So I want to do 180 plus the 59.34 because I just surpassed the 180 mark. And that comes out to be 198.26. Solution set, here you go. I like drawing the picture. I think it makes sense to me. You can also come up with if it's got to be in the second quadrant, I take this angle and subtract. There's lots of different ways of doing it. I think visually the picture makes the most sense, but again, that's up to you guys. All right, let's finish it off with number 12. The tangent inverse of negative 6.5. This is what the calculator gave me. Ugh. Negative 81.25. Again, that does not fit in my answer set for the solutions. So I have to come up with how am I going to figure that out? How am I going to figure out what angles I want? Well, I want tangent to be negative. If you look back up here, tangent is negative in the second and the fourth quadrant. The reason is because cosine is negative here, sine is negative here, and the other one is positive. So in terms of 81.25, if I was graphing that or drawing that angle negatively, that would be here, 81.25. Also, same kind of concept here, right? This is going to also be 81.25. So what I need to figure out is this angle that ranges from here to here, and I need to figure out the angle that ranges from here to here. So the blue and the orange. Well, in terms of the blue, if I were to finish the blue off, I would be making 180. But I'm taking this piece out again. I'm taking the 81.25 out so I can have what's left. So I need to do 180 minus 81.25. And that's going to give us 98.75. Then for the orange, I want the whole angle that ranges from here to here. If I extend, I have 360. If I do 360 minus the 81.25, that'll give me what's left over. So minus 81.25 for that one. So check to make sure that you're getting those answers. Check to make sure that it's making sense why I'm picking what I'm doing here with the adding and the subtracting. You can kind of start seeing a pattern. If you land here, you add. If you land here, you subtract. If you land in the first quadrant, you just keep that answer. So there's a couple of things that you can kind of work through there so that maybe you don't have to draw the picture. Homework, keep in mind, get those things done. Otherwise, have a great day and peace out.